Hi guys, myself Radheja. Today I'm going to explain the topic, explain the phases of compiler. Let us start with introduction of compiler. An overview of a key concept, the functions of compiler, including its roles in translating the source code into the machine code. Let's see what are the types of compiler. Like lexical analyzer is the first type, and syntax analysis, and semantic analysis, and intermediate code generation are front-end machine independent. Whereas code optimization and target code generation are backend machine independent. Backend machine dependent, not independent. Let us explain about lexical analysis phases. In this lexical analysis, that's a summary about lexical analysis. These are the token or pattern or lexeme, and these are regular languages we can be used, and regular expression, and it is the computational model and tools, and it is also called finite, and it has a finite automata. And Lexisar uses the automata and longest lexema rules, and these are the programming assignments. In lexical analysis, the token generation has been made. Like in the process of breakdown the source code into the tokens are further processing, analysis, and the pattern matching and matching into the tokens with defined patterns and identify the language syntax rules. Let us say the syntax analysis phases. The syntax analyzing or pacing is the second phase. After the lexical analysis, it checks the syntactical structure of the given input, whether the given input is correct syntax of the language in which the input has been written or not. It does not show the by building a data structure called phaser tree or syntax tree. The phaser tree is constructed by using predefined grammar of the language of the input string. If the given input string can be produced with the help of syntax tree in the derived process, the input string is found to be a correct syntax. If not, the error is reported by syntax analyzer. Syntax analyzer steps to be implemented like phaser implementation. The utilizing the grammar rules to create the phaser tree and verify the correct syntax of the tree of the code, or error handling. That is detecting the report syntax error and improving the code quality and developer experience. In the semantic analysis process, we can type check the and ensuring the compatibility and the data types, leading the robust and reliable code execution. In the end, in syntax semantic analysis phase, the symbolic table creation and building a symbol table to track the variable declaration and the scope for the semantic validation. The intermediate code generation phase. In the analysis synthesis model of the compiler, the front end of the compiler translates a source program into a independent intermediate code. Then the backend compiler uses this intermediate code to generate this targeted code, which can be understood by the machine. And this intermediate code that can be which done in backend compiler use this as an intermediate code generation to generate targeted code, which can be understood by a machine. The machine can be understood this intermediate code generation. What are the benefits of machine independent intermediate code generations are? Because of machine independent intermediate code, the portability will be enhanced. For example, suppose if the compiler translates the source language into a targeted machine language without having the option for generating intermediate code, then for each new machine, the full native compiler is required, such as that a compiler translates a source language to a particular given target language without having a function for the option for the generating a intermediate code. Then then the new machine will be full native compiler required, because obviously there was no some modification in the compiler itself according to the machine specification, and retargeting is facilitated, and it is easier to apply the source code and modify it to improve the performance of the source code and optimize by the intermediate code. In intermediate code generation, there are expression tree, which can be constructed the abstract syntax tree to represent the code expression and optimize their evolution. And the tree code generation, the generating the intermediate code with the clear variable operation and facilitating the further optimization. In code optimization phase, the constant folding, like replacing the constant expression with evaluating result for enhancing the runtime performance. In loop optimization, the applying the technique to improve the efficiency of the loop and reduce the redundant computation. In code generator, the instruction section in the first section, the chosen machine instruction to implement the intermediate code operation. Like intermediate code should be chosen from the machine instruction and register allocation, assigning the machine register to the perform variable for the efficient execution. Code emission, the outputting the final code based on the allocated register selected by instruction, like outputting the final machine code based on the allocated in this register allocation and selected instruction base. Like in the conclusion, what we learn from this process of the compiler, like compressive process, the transfer of human reliable code into the machine executable instruction is we can translate the machine readable code into the machine executable instruction is known a compressive process, where what are the critical role we have been enhanced from this compilers are enable the functionality and performance of the desired software application, like desired software application we can be enhanced from this phases of compiler.